Pythagorean theorem is something that only works with right triangles, okay? This is a famous theorem. What a theorem is something that has been proven to be true, okay? When you see a theorem, it's something that has already been proven to be true for all cases. Okay, so in this theorem it says if you have a right triangle, then, so we start out with the idea we have to have a right triangle before this ever works. Okay, that's what it says, if you have a right triangle. Now, what does it mean to have a right triangle? What does that mean? Yes?
One of the angles is 90 degrees.
One of the angles is 90. Can I have two angles that are 90 degrees in a triangle?
No.
Okay. Marcy, why not?
Because then it wouldn't be a triangle.
Okay. Because if I have two 90 degrees, let's just look at it. If I have two 90 degrees, look what we get. That's not a triangle. We have to have only three sides.
The two lines would be parallel, so they would never.
Yes, they would never touch each other, so they will never be a triangle. Okay, so that we know there's only one angle, one 90-degree angle in the triangle. I'm just kind of putting this down as a reminder. That's what a right triangle actually means. That's a definition of a right triangle. It has exactly one 90-degree angle inside. Okay. Then, well, we have to know a few things about the triangle. Okay. We have to know that what the legs are. So then the legs squared. Okay, well, what are legs? What do you think are the legs? Yes.
The two lines that make up the 90-degree angle?
Yes, the two sides of the legs are this one and this one, because see how they make the 90-degree triangle. So the legs are the ones that make the 90-degree triangle. So the legs are the sides of the 90-degree angle. Okay, so that's how we identify the sides. Okay, squared and added together equals the square of the hypotenuse. So what is the hypotenuse? How would you identify the hypotenuse on this drawing up here? Lil, how would you identify what is the hypotenuse? Looking at your picture, what do you think the hypotenuse is? Give you a hint, it's not the legs. You don't know, okay?
Shapes.
Ooh, well, we're learning them, okay? Gavin, what do you think? What's the hypotenuse up there? So if I have two legs, this side is a leg, this side is a leg, take a guess what the hypotenuse is. Gavin, just take a guess.
I have no idea.
Okay, Jonathan, take a guess.
The slanted end on the right.
Yes, it's the other side. It's the missing side. Okay, the missing side that's not a leg is called the hypotenuse. Okay. Guess what's true about the hypotenuse? There's always something true about the hypotenuse. Yes.
The theorem.
Well, now I know one about the theorem. Just looking at it, what can you see about the size of the hypotenuse compared to the legs?
It's usually bigger.
Yes, the hypotenuse is usually the longest side. Okay, the hypotenuse is the longest side. Another way to identify it is it's the one directly across. It's like the right angle sign points to the hypotenuse. Do you see the point there to the hypotenuse? It's the side opposite the right angle. That's another way of saying it. It's the side opposite the right. That's a symbol for a right triangle, or right angle is right like that. That means right angle, okay? So this is the third side, the longest side, or the side opposite the right angle, okay? So those are different ways of describing what the hypotenuse is, okay? I don't really care if you can tell me that. I want you to be able to identify the hypotenuse, okay? If I give you a triangle, right triangle, you better identify that, okay? What this tells me, it's a bunch of gobbledygook that we just need to know basically that it's a right triangle. Yes, it has a right angle in it. We need to know that the legs squared and added together equal the square of the hypotenuse. Well, that's a bunch of gobbledygook. We always call the hypotenuse C in our theorem, okay? We always call one leg A and one leg B. It doesn't matter which leg is called A and which leg is called B. They're both legs, so you just can make one of them A and one of them B. So what you're doing is you're taking the length of A, you're squaring it, you're adding it to the length of B squared, and that will equal the length of C squared. That is the Pythagorean theorem. But you have to remember the if part. You have to have a right triangle before that's true. Okay? So this does not work for any triangle. It only works for right. Well, I'll write it this way. Right triangles. And sometimes people forget that. The if part is if you have a right triangle. You have to have a right triangle before a squared plus b squared equals c squared. Well, for one, it would be very hard to identify the hypotenuse if it's opposite the right angle if you don't have a right angle in your triangle, okay? It would be very hard to say, well, the legs are the side of the right angle, but if you don't have a right angle in your triangle, then you don't have legs because there's no right angle in the triangle, okay? So it really does fill out, but you have to make sure you say it's if you have a right triangle, okay? So that's really what 2.5 is all about, is using the Pythagorean theorem. Now, let's just do a couple. They're going to talk about a couple, but we're going to do some just to show how you use this and how you solve. Okay, so we're going to use the Pythagorean theorem. Just die? No. Use the theorem. Okay, I have this triangle. I have A, B, C. This is told that it's 90 degrees. This is how I indicate that something's 90 degrees. I make a square out of it. A square has all 90 degrees in a square, so that's why you make a square. Yes?
Are we starting a new page here? Like
It's more notes. So now you're doing an example problem. That's what we're doing. We're going to use the theorem. We're going to do an example problem. Okay, again, friend, do you have some paper to write with?
Yeah, I'm right here.
Do you have some pencil?
Mm-mm.
Oh, we don't have a pencil. You guys need to make sure you come to class with a pencil. Can he still borrow your pencil? Thank you. Please bring pencils to class. If you think you're going to forget pencils, bring some that are sharpened and put them in here. And you can always grab one out of here. It's a storage spot. Okay. So you should always bring them to class. Okay, if I know that this is 5, this one is 12, and I want to know what that side length is. Okay. So which one am I actually looking for? Because yes.
The hypothesis.
Yes, we're looking for the hypotenuse. Okay, it's a hard word to say. Think of hypnotist, that's pretty close. If you say hypnotist, I'll take it. Hypotenuse. Okay, so our formula is a squared plus b squared equals, not plus, equals c squared. We know that's true because it's a right triangle. Okay, I look, I check. Right triangle, yes. So I'm asking myself, right triangle? Yes. Okay, that means this is true. Okay. What number, what size would you like, or which side would you like to call A? The one that's the length 5 or the one that's the length 2? Lil, give me, which one do you want to call? It doesn't matter. Do you want 5 or 12 to be A?
5.
Okay, so she's going to say that A is equal to 5 because that's one of the legs. Okay, that automatically makes this one B is equal to 12. Okay, it doesn't matter which leg you make A or which leg you make B. It will work the same way. We are looking for C. That's the question mark. Okay, so we don't have this. We do have A, so I'm going to put 5 in here and I'm going to square it. All I'm doing is substituting what A is, the length of the leg, plus I'm going to substitute what B is. B is 12 squared, and that still equals C squared. Okay, so all I did there was substitute 5 in for A, 12 in for B, because we know that's how we labeled them up here. Okay, so we're just plugging them into the equation. That's called substituting them in. The reason we know is we just said A was 5, so I'm going to make it a 5. We said B was 12, I'm going to make it a 12. Okay, what does it mean to square something?
You multiply it by itself.
Yes, okay. So, does somebody tell me what 5 squared is? Okay, Gavin, what is 5 squared?
25.
It is 25 because 5 times 5 equals 25. That's what squaring means. Multiply the 5 by itself. Okay, so now I need to know what 12 squared is. Anybody want to tell me what that is besides the 2 that are always raising their hands? Ezekiel, do you know what 12 squared is? That's 12 times 12. Do you know what that is?
No.
Okay. Anybody else know what 12 times 12 is? Okay, Jonathan.
144.
144.
And
That's equal to C squared. Okay. Order of operations is to do the squaring first, the exponents first, before we add. Okay. So now I have 25 plus 144. Well, that's a pretty easy addition problem. It's 169 equals C squared. So what am I actually going to do? What do I have to find the length of C?
you have to figure out what times what equals 169.
Yeah, what times itself equals 169. Another way of doing that is this. you take the square root sign. So on a calculator, there's a square root sign. It looks like this. It's not a division sign, it's a square root sign. You take the square root of 169, and that will equal C, okay? Because the square root, what it finds is what number multiplies by itself to give you the number inside. And what do you get?
13.
13. Because 13 times 13 is 169. So that tells me the length of my hypotenuse is 13. Okay. So that's basically one way to use the theorem. We're going to do one more example. One more example. Okay, let's look at this one. Okay, first, is this a right triangle? Marcy, is that a right triangle? Yes. Okay, so that means we can use the Pythagorean theorem because it's a right triangle. Okay, so what is the statement that the Pythagorean theorem tells us is true? Yes, go ahead.
That there's a missing leg.
Yeah, we're looking for a missing leg, okay? So what's the actual statement though? What's the equation I can write out that's true for any right triangle? Yes.
It would be
Now, don't give me the numbers here. It'd be
like a squared plus 5.
now plus b squared equals c squared, because we want to start with that every time, okay? Now we have to identify what do we have, okay? So looking at our picture, Ezekiel, 3, is that A or B or C?
B.
Okay, it can be B. So we're saying that B equals 3. What can it not be? What can the 3 not be? What letter can it not be?
C.
C, because it's not the hypotenuse. It cannot be C. Okay, so what is 5? If I look at the 5, what is that letter going to be? A or C? Yes.
C.
Why?
Because it's the
That word,
yeah,
yes.
whatever.
That hypotenuse.
Whatever it's called.
The longest side. You can just say the longest side. I'll take that because that is one way of saying that it's the hypotenuse if it's the longest side. So now we're plugging those into our equation. We don't have A. So we just keep A squared there. We keep that number there. Okay. Plus, we have 3 squared. Okay. Equals 5 squared. Okay. So let's do the math that we can do. We can't do anything with A squared. What is 3 squared? Lil, what is 3 squared? That's 3 times 3.
18.
Not quite. 3 times 3.
Brain's too small for them.
Oh, that's okay. So, Peyton, what is 3 times 3?
9.
9, yes, it's 9. What is 5 times 5, Gavin?
25.
25. Now, I'm not going to show you how to solve this. Just a minute. What would A squared have to be so when I add 9 to it, it makes 25? Just tell me what that, looking at that problem, what would A squared have to be to add it with 9 to make 25? Yes.
You would have to subtract the 2.
You could subtract the 2. What else? How else could you just say something plus 9 equals 25? Can you figure out what that number is? Okay. What do you guys think? Ezekiel, what is that? What number plus 9 equals 25? Oh, come on. Think about it. If I add 9 to a number and I get 25, what would that number be? It's not quite 17, oh, really close.
16.
It's 16. So this number has to be, because 16 plus 9 equals 25. That's a true statement. So a squared has to equal 16. So a is going to be the square root of 16. I hope all of you can figure out what the square root of 16 is. What times what gives me 16? It has to be two numbers that are identical. What two numbers, Marcy?
8. No.
8 times 8. No, not quite.
Oh.
Okay, let's see. Okay, Brownson.
4.
A is 4, because 4 times 4 equals 16, so A has to be 4. Because what we're looking for is, what did I multiply to get 16? I multiplied 4 by, or what did I square to get 16? And it was 4. Okay, so this is a little bit of a different problem. You again need to make sure you identify correctly. If you're given the hypotenuse, that needs to go in as C. It has to go in as C if you're given the hypotenuse. Okay. Now there's other ones that we're going to do. They're going to do some ones that ask you if they're Pythagorean triples. Okay. And what this is, it's just if we have a Pythagorean triple. That is 3 numbers. We'll do 6, 8, and 10. Okay. 3 numbers that when I put them into the Pythagorean theorem, they are true. Okay. Now again, the hypotenuse is always going to be our largest one. So what a Pythagorean triple is 3 numbers that make the Pythagorean theorem true. Okay, that's what a triple is. 3 numbers that make the a squared plus b squared equals c squared true. Okay, that's what a Pythagorean triple is. So if we want to check to see if it's a Pythagorean triple, okay, we would put in, I'm going to make this A, this B, and this C. This one definitely has to be C because it's the longest side. Remember, C is always going to be the longest side. So that has to be C. It doesn't matter which one's A or B. But we're going to check, does it make it true? If I do 6 squared plus 8 squared, does it equal 10 squared? Okay, so Hayden, what is 6 squared?
36.
It is 36, because 6 times 6 is 36. Okay. Ezekiel, what is 8 squared? That's 8 times 8. What does that equal? Okay, you guys need to learn your multiplication tables. You will not go far in math if you don't know your multiplication tables, so practice them. It's 64. Without a calculator, we should be able to do it, okay?
Okay, without a calculator, 64.
Okay, what is 10 squared? Lil, what is 10 times 10?
100.
100. Okay. So we're checking to see if these are triples. If it's triples, then this statement should be true. Well, what is 36 plus 64? Yes,
100.
it's 100. 100 equals 100. Is that a true statement?
Yeah.
That's true. So this is a set of Pythagorean triples. Those 3 numbers do make the Pythagorean theorem true. Okay, let's just try another one. Whoa, I can't walk. How about we do 5, 7, and 11. 5, 7, and 11. We're going to check to see if it's true. Okay, this one has to be C because it's the longest one. Okay, doesn't matter what the other 2 are. One's A, one's B. So we're going to check. 5 squared plus 7 squared equals 11 squared. Ooh, now I'm asking you to do some harder work. Okay, Hayden, What is 5 squared?
5 squared, 20.
25. Peyton, what is 7 squared? 7 times 7. Just put your hands down. Let her have a chance. Okay, Branson, would you help her? What is it?
49.
It's 49. Again, multiplications need to be, so practice your multiplication tables. There are all sorts of ways. Go on the internet and just say multiplication game. And there's all sorts of games you can play practicing your multiplication tables. Okay? It's important. You need to know how to multiply up to 12 times 12. I don't care if you know farther than that, but you should know how to do multiplication up to 12 times 12. If you don't, you need to practice because it's going to make your life more miserable because we are going to do things and I'm going to expect you to know those. You should have known those in about 3rd grade. Okay? So you need to go back, review, refresh, get yourself so you know that. Make flashcards. Go over those flashcards every night. Do something. Quiz each other. Do something to make it so that you know your multiplication tables. Okay? So this is 49. Can somebody tell me what 11 squared is? Okay. Yes, John.
121.
It's 121.
Which equals 74, which is not true because.
Okay, this and this, he's already doing the work for us. He's eager to give me the answer. So 25 plus 49, that's 69 plus 5, which is 74, is not equal to 121. Therefore, these are not Pythagorean triples. Okay, so that's what we're looking at on that one. Okay, you're going to have problems similar to that. Okay, so go ahead and take a break right now.